Hi children, welcome to my YouTube channel. This is the fourth video of the topic series Moments. In this topic we are going to discuss about tilting objects. What do you mean by tilting? To understand what is tilting, I'll tell you a simple example or experiment you to try. Take a rod and keep it on two supports, just like as shown in the diagram A and B. Then add some weight to the corner from B. I am going to explain from this diagram, that is why I am asking you to add a load from point B, not from the side of the point B. If you add small mass to that corner, at one extent you can understand that this rod tends to swing from A. Swing from A means the contact from A become uncontacted, it will reduce, or there is no contact from A. This condition is called the tilting. As shown in this diagram, if the object tends to tilt at A means this tends to balance at B, tilt at B means balance at B. If this object tends to balance at B, the contact from A get discontinued. As a result, the reaction at A becomes 0. So in any question, if they specifically mention object tilts at one point, as on this diagram it's tilt at B, the reaction at the other support becomes 0. This is the condition we can verify or we can explain for the situation of tilting an object. Hopefully you understood this concept over here. Let's try to understand how to work out or how to use this concept in our questions in moments. The other important point is, if an object remain in tilting condition even, we can apply the same theories where we used to solve a question where the object remain in equilibrium. Remember that if you extremely exceed tilting only, it will break up the conditions of equilibrium. Other than that, just at the point of tilting even, we can use the same condition where we need to solve the question which is in equilibrium. So you can work out the resultant force is 0 and as well as resultant moment is also 0. So here that is the other important point we have to understand when you are working out with these tilting conditions. Okay children, let's try to come up with this question. This question says a uniform rod AB of mass 45 kilograms and length of 16 meters. What are the facts you can understand from this statement? The rod is uniform. Therefore, the center of gravity is exactly the midpoint of 16 meters. That means from corner A or corner B, it's at a length of 8 meters. The mass is 45. Therefore, the weight is 450. So, in this diagram, you can mark 450 exactly at the midpoint of this rod. That's the first fact we can mark. Horizontally on two supports, it was kept on two supports C and D, where AC is 5 meters and CD is 9 meters. It's shown in the diagram, right? When the child stands at A, the beam is on point of tilting about C. I haven't mentioned anything about how to mark the reaction. That is why I just wait for the next statement. When an object stands at A, what happened? The beam on point of tilting about C. That means it's balancing at Z. Means the contact at D become discontinued. As a result, the reaction at D becomes 0. So you can mark the reaction over D is 0, or you can just keep it blank without marking any information. Then the total reaction comes to C. Then you can mark the reaction at C as R. And you can mark the weight. We don't know the mass of the object. Therefore, I'll mark just mg downwards from point A, since the person or the child is standing at point A. Okay. In this diagram, we have already marked the information where I have explained in the previous slide. If I brief out, since the object is, or the rod is tilting at C, the reaction at D becomes 0. And since the the rod is a uniform rod. The center of gravity is exactly midpoint of the rod, the length 16, therefore the midpoint is 8 meters from corner A, and as well as the entire reaction work out with the point C. That's the main thing to understand. Since this is in equilibrium, to obtain these answers, I can use the moment around point C. If I consider the moments around point C, you can say the clockwise moment equals to anti-clockwise moment. The anti-clockwise moment is mg into 5 meters. That is the moment due to weight. So therefore you can weight of the person. So therefore you can work out 5 into mg. That is equals to clockwise moment. What is the clockwise moment? That is the moment due to the weight of the rod. That is 3 meters into 45 g. If you simplify this the problem, you will understand that m is equals to 27. Therefore you can say the mass of the child is 27 kilograms. That is the answer for this question. And if you just give a small little bit explanation for this question, if the mass of the child is less than 27, what happened here is that the rod is not tilting, therefore there would be a reaction at C and D as well. And if the mass of the child is 27, object is about to swing from point D, therefore the reaction at D becomes 0. So in that case, under these two conditions, objects remain in equilibrium. But if the mass of the child is exceed 27, definitely he cannot stand like this. The rod will topple and it will rotate or swing at point C, and the system break up with the equilibrium and the child will fall from that corner. There is another important point I want to highlight when you are working out with this question. That is, when you are considering these moments, I haven't considered the moment due to RC. What is the reason? The reason is we have considered the moments around point C, therefore the RC is traveling to C. So the moment due to RC would be 0. So that is another important part. I couldn't explain when you are working on the moment part. So that is how you need to get the reaction. The moment due to reaction, that would be turned up to 0, since we consider the moment point as the same point where the reaction acts. If we start with this question, the question is a non-uniform rod AB. If the rod is non-uniform, the center of gravity is not at the midpoint. Sometimes in this question, they might given us the length from center of gravity from one corner, or sometimes it might be the reason where we need to find it. I think we have done similar question in our previous video as well. The length is 10 meters and weight is 40 newtons. So still we don't know at which point we have to mark this 40 newton. Is suspended from pair of light cables attached to C and D, where AC is 3 meters and BD is 2 meters. That is the point you have to understand, right? Okay. Then still we cannot mark any fact about the tensions on these rods at the situation, because there may be some kind of extensions given for this question. So keep it as it is, right? When the weight of 25 Newton is hung from A. Now children, if you hang a rod from two rods like this, and if you hang a weight from A, what you can understand is, if you increase the weight, definitely this will tend to tilt from one point. So how to understand this condition? When a weight of 25 Newton is hung from A, the rod is on point of tilting, and find the distance of center of gravity of mass of the rod from A. So you can understand that children, if you increase the weight from A, from which point it tends to tilt. So if you increase the weight, you can understand that the possibility of happening a tilting condition would be from point C. Therefore, the condition where we can because here they haven't given us what is the point of tilting, therefore we need to understand that the chance of having tilting, the firstmost condition is the tilting around point C. That means the reaction at D become 0. Then we can mark the information as shown in the diagram. Now children, we can mark the same equilibrium conditions to get this answer for this situation. Then I'll consider the moments around C. Right. Then if you consider the moments around C, there won't be any reaction or any tension comes from tension T1. That's the point you have to understand. And if you consider the moments around C, the clockwise moment is equals to anticlockwise moment. The anticlockwise moment is 3 into 25 newtons. And yeah, the other one is weight of the rod. From where the weight of the rod acts? I will assume that it will act from x distance from A. The length from A to the point of weight is center of gravity is x. Therefore, if you consider the length from C to that point would be how much? That's the point you have to understand. A to that point is x, A to C is 3, therefore C to that point would be x minus 3. Therefore, you can say 25 into 3, the anticlockwise moment equals to 40 into x minus 3. That is the clockwise moment. Hopefully you can understand from where this x minus 3 came, right? Then if you simplify this, you will understand the condition x is equals to 4.875. That means the object remain in equilibrium if the center of gravity of this non-uniform rod remains at a distance of 4.875 meters from corner A. That is a condition where we have to understand from this question, and that would be the final answer for this question. If you focus on this question, the question is uniform rod AB has a length of 5 meters and weight 20 newtons. So in that case, you have to understand, you have to mark the weight of the object 20 newtons, exactly midpoint of length AB. The reason is that the rod is uniform rod, right? The rod is resting in a supports at point C and D, where AC is 2 meters and BD is 1 meters. Find the magnitude of the reactions at C and D. That's the first part of the question. The second part of the question is the particle of weight 12 Newton is placed on rod at point A. If you keep any mass on that one, what is the condition where we can expect? That means if you keep it from point A, it has a chance of tilting at C. If the weight added here is too much for this object. So that is a condition where we can expect. Show that this causes the rod to be tilt about C. That's the second condition we mentioned, right? A second particle of weight 100 Newton is placed on rod at E to hold it in equilibrium. Find the minimum and maximum possible distances from E to A. So how do we work out with this question? So the theory we are here to understand is, if object tends to tilt, what we can do is we can keep another mass at a different point and we can balance the system. So let's try to understand how to answer this question. Here the part A is the same thing what we have practiced in our moments 3 tilt as well. So you can work out upwards forces equal to downward forces since this is in equilibrium. So upwards forces are RC and RD. Downward force is 20 newtons. So you can get the first equation, RC plus RD equals to 20. Then I'll consider the moments around C. If you consider the moments around C, there are two forces like the moment due to reaction RC can be ignored since it's passing into the same point. The other moments occurs due to the force of 20 newtons and RD. The moment due to 20 newton would be 0.5 meters into 20 newtons, which is clockwise, and anti-clockwise would be 0.5 plus 1.5, that is 2 into RD. So you can work out clockwise moments equals to anti-clockwise moments since the object is in equilibrium. So you can say 20 into 0.5, that is the moment due to the weight, is equals to RD into 2. Now we know by solving this equation you will obtain the answer for RD as 5 newtons. From the first equation you can say RC become 15 newtons. That is the answer for part A. Now children, when you add a mass to point A, another weight 12 newtons act on point A. As a result, the system totally different. So now you cannot obtain any of the answers where we calculated previous question for RC and RD. That would be totally changed. If you add another mass, or if you change the position of this what you call that supports or the pivot points, whatever the condition, the total condition changes from the previous situation. Therefore, now RC and RD are not the same thing as before. Now let's see. If you put a mass at point A, they mentioned that object tends to tilt at C. That is what we need to show. That means you have to show that this RD become 0 or some kind of an impossible value over here. That is a way of proving that object is tilting at point C. That means which is point C, the RD must be 0, or you have to say that RD obtain some kind of a impossible figures, right? Then if you add a weight of 12 newtons, if you consider the moments at C, you can understand that there should be one clockwise moment and two anti-clockwise moment. What is the clockwise moment? That is the moment due to 20 newton, or the weight of the rod. What is that amount would be 20 into 0.5 meters. Okay. Then what are the anti-clockwise moments? The moment due to 12 newton. So you can understand, if you consider the point from C, keep your finger from C, and if you push the diagram from A, it makes a anti-clockwise rotation. Then if you keep your finger at C and if you push from point D as shown in the diagram, even that one also tends to form an anti-clockwise moment. So the anti-clockwise moment's addition should be 2 meters into 12 newtons plus 2 into RD. You can understand why it's 2 came from C to D. The length is 0.5 plus 1.5, that is 2. 2 into RD. If you simplify this, you will obtain the answer for RD as a negative value. Can a reaction be negative? Obviously, we know that this is impossible. Therefore, you can say this is not in further condition where there's a contact between D and the rod. That means definitely the object tends to tilt from C. That is how you need to prove it. Either you can show RD is equals to 0, or you have to show RD is an impossible value to show that it's the object is tilting. Then children, some of you may question that why didn't we get any negative value for RD in our previous question? The theory is there they mention its point of tilting. That means at a point of just balancing at the the support where it's tilting. So under those conditions, we can mark it as the reaction at the other corner as 0. So no need of marking at 0, but only thing is that if they ask us to prove it's tilting, we can show it's a the reaction at the other support is 0 or some kind of a impossible figure. Now children, when you come up to part C, again we need to balance the system. Therefore, we need to put a weight at some kind of a point in between C and D to balance. So from practical sense, you to understand that if the object is tends to topple from point C, we have to keep a mass in between at a point in between a point from C to D. From there you can balance the system. Now let's see at which point we have to place this the new mass 100 Newton to keep the system is in balance. So we will assume that we have to keep that mass from a distance of simple x from point A, just as shown in this diagram. So in that case, again now it's not tilting. Therefore the reactions become again change. There would be a reaction for C and it would be a reaction for D as well. Now I told you that if you add a mass or if the point of support changes, the reactions are not same as before. So therefore don't misunderstand. You cannot use any figure where we have calculated in previous setup for RC or RD. So those are totally new values. Now children, here we need to bring this object into the least equilibrium condition. That means the total toppling condition should be just brought in a way balanced with C. Therefore, we can mark at the least condition the reaction at D become just 0. In the previous condition, you get a negative answer, means what happened? Totally tends to topple. But if you want to just balance at C, what you can do is just like it's tilting at C. That means the reaction at D you can consider as 0. With that assumption, we will consider the moments around C. If you consider the moments around C, you can mark 12 into 2. That is the anti-clockwise moment where we can obtained from this question, that is due to the weight you added 12 newtons at point A, 2 meters into 12 newtons. Then there is no reaction, no moment due to the reaction RC. The other one is, children, the moment due to the weight of 20 newton, the weight of the rod. The length from A to M is 2.5, A to C is 2, therefore that length should be 0.5. So you can mark 0.5 into 20 newtons. So other than you can say 20 into 2.5 minus 2. 2.5 minus 2 comes because the length from A to M is 2.5 and A to C is 2, therefore C to M is 0.5. So that moment would be 0.5 into 20. Then the other one is the moment due to 100 newtons. So we consider the moment around C. We know that A to E is x. Then A to C is 2. Then C to E would be how much? X minus 2. That is the total x minus that value. Therefore, that moment would be 100 into x minus 2. So if you simplify this, you will obtain the answer for x as 2.14. So in that case, if you keep the mass of 100 newton at a distance of 2.14 from A, you can brought back this object into the equilibrium. That is how you need to do this question. Hope you have understood the contents in this video. If you like this video, put a thumbs up and share this video with your friends. To watch more educational videos, please subscribe my channel and click on the bell icon. Thank you.